Okay, so let's go ahead and take a look at this section. So this section is using some basic Pythagorean identities in order to be able to simplify expressions. Okay, so an expression is different from an equation because an equation has an equal sign and an expression does not. So we know that sine is opposite over hypotenuse, which is the same thing we could say as 1 over cosecant. Because remember that cosecant is 1 over sine. So I could always like invert that and use that to help me simplify. Cosine is adjacent over hypotenuse. So that also means that I could go 1 over secant. Tangent is opposite over adjacent. So that is also, we talked about it before, I think, is sine over cosine, which I could also say is 1 over cotangent. And then cosecant is hypotenuse over opposite. So we say that that's 1 over sine. And then hypotenuse over adjacent is secant. And that's 1 over cosine. And then cotangent is adjacent over opposite, which is cosine over sine, or 1 over tangent. And you do have to memorize all these. You're going to need all of them. Okay, so now you have what's called the Pythagorean identity. It comes from the Pythagorean theorem. And I didn't make you guys prove it before, but you can prove this this theorem to be true using the Pythagorean theorem. And so that's why we call it a Pythagorean identity. But essentially, whenever I see sine squared plus cosine squared, I can substitute in 1. I could also say that 1 minus cosine squared is equal to sine squared, because I can just subtract my cosine squared to the other side. I could also say 1 minus sine squared is equal to cosine squared theta. Okay? I was like, my stomach is growling, so I'm gonna have to eat breakfast soon. Okay, so when I look at this, I can also create more Pythagorean identities by doing a couple things. I can divide everybody by cosine squared. And then when I do that, so divide everybody by cosine squared, and I get tangent squared plus 1 is equal to secant squared. And so now I have a new identity. So anytime I see tangent squared plus 1, I can substitute in secant squared. I could also say that 1 is equal to secant squared theta minus tangent squared theta. I can also say that tangent squared theta can be substituted in when I see secant squared theta minus 1. So now I have a few more identities that I can use for substitution just to try to simplify things. I could also divide by sine squared. And when I do that, I'll get 1 plus cotangent squared is equal to cosecant squared. And so then I can have another identity here. I can subtract again. I get 1 is equal to cosecant squared theta minus cotangent squared theta. I can also say that cotangent squared theta is equal to cosecant squared theta minus 1. So now I have a few more identities that I can look at. Okay, so now I'm going to just use what I know, and that's where you might want to have this, like kind of this paper right here, like kind of next to you as you guys are practicing, so you get good practice with it. Just remember, you have to memorize everything for your upcoming quiz and test, which is going to make things a little bit more difficult. Okay, so tangent is the same thing as sine over cosine. And then what you notice is that the cosines cancel out, and I'm just left with sine. Cotangent is the same thing as cosine over sine. Tangent is the same thing as sine over cosine. I could have changed one of these into 1 over tangent or 1 over cotangent to realize that everything is canceling out and I'm left with 1. Okay. Tangent squared, so tangent squared, so that's sine squared, sine squared theta over cosine squared theta, and that's over 1 over cosine of theta. And so I'm going to take this, so sine squared theta over cosine squared theta, and I'm going to invert and multiply. And one of my cosines goes away, so I'm left with sine squared over cosine of theta. And I can split this into sine of theta, cosine of theta times sine of theta, because it's all multiplication. So there's no addition or subtraction, so there's no holding hands of any sort. Okay, so then I get tangent of theta times sine of theta. We just talked about this. 1 plus tangent squared is secant squared. So I'm going to change this. So I have cosine of alpha over sine of alpha. So that little weird looking A thing is called an alpha. And then my secant squared is 1 over cosine squared of alpha. And then I have sine of alpha over cosine of alpha. So when in doubt, change everything into sines and cosines and then try to simplify. Okay, so I can get rid of one of my cosines. I'm left with 1 over sine of alpha. And then I can invert and multiply my denominator. And then what you realize is that this is cosecant of alpha times cotangent of alpha. Okay. So now sine squared, remember we just talked about this also, is cosine squared. And then cosine cubed. And so what you get is you get a square that cancels out, and you get all of your cosines except for 1 and the denominator cancel out. So then you get secant of theta. Okay? And now here with this one, I'm going to use the box to multiply out my numerator. So I have secant of x plus 1, secant of x minus 1. So I get secant squared of x, secant of x, negative secant of x, and negative 1. So I get secant squared of x minus 1 over sine squared of x. Secant squared of x minus 1 is going to be tangent squared theta. And this is over sine squared theta. So then I get sine squared theta over cosine squared theta divided by sine squared theta. And that's over 1, so I can invert and multiply. So sine squared theta over cosine squared theta times 1 over sine squared theta gives me my sine squareds go away, and I'm left with 1 over cosine squared, which is the same thing as secant squared. Okay? Last couple here. I was going to say last one, but then there's 2 more. I'm going to find a common denominator, which is both of these terms. So I'm going to take my cosine of x over 1 minus sine of x, and I'm going to multiply the top and bottom by cosine. And then I'm going to take my sine, and it's over cosine, and I'm going to multiply by 1 minus sine over 1 minus sine. Okay, so what I get is I get cosine squared of x, and I get 1 minus sine x times cosine x. And what I get is minus sine of x, because I'm going to take this negative with this sign, and I'm going to distribute here, and then I'm going to distribute here, and then I get a plus sine squared x. And so what you notice is that this sine squared and this cosine squared gives me 1. So I get 1 minus sine of x in the numerator, 1 minus sine of x in the denominator, and a cosine. And then what you notice from there is that when my 1 minus sines go away, so I'm left with 1 over cosine, which is secant. Okay. Example 8, we have our greatest common factor, and that greatest common factor is sine. So I factor out a sine. I'm left with 1 minus sine squared, and it's not theta, it's x. And then 1 minus, here my 1 minus sine squared is cosine squared, so this is sine of x times cosine squared of x. Okay, and that is it for this lesson.